Hello everybody, my name is Rahmat Khan and I'm here to teach you guys Chemistry 5070. Let's start with today's topic. Today we're going to study the particulate nature of matter 2.5, which is covalent bonding. And the learning objectives for today's class are that we are going to study the formation of a covalent bond, how is it basically formed, and what kind of atoms or elements are involved during the formation of a covalent bond. Then we're going to continue with the dot and cross diagrams to form the covalent bonds, and we're going to deduce the arrangement of electrons in covalent molecules. Then I'm going to tell you how we can relate the physical properties of a covalent compound to their structure and the bonding they have. So let's begin with the first slide. So first of all, if I talk about how the covalent bonds are formed, uh, it is necessary to understand first that the atoms or elements which are involved in chemical bonding, they are basically involved because of attaining a noble gas configuration, which is 8 electrons in their outermost shell. So sometimes what happens that some atoms or elements they have to emit or large amounts of energy, or there is large amount of energy which is required uh, so that they can lose or gain their electrons. So what they do is they do not form cations or anions as we learned in ionic bonding. So if they do not want to transfer their electrons, what they can do is they can those atoms they gain their stability, or of course they need to have the stability of a noble gas configuration, electronic configuration. So what they do is they do not lose or gain their electrons, but they just share the electrons, and that kind of chemical bonding is going to be known as the covalent bonding. And the bond which is formed between the two atoms or more than two atoms, it is going to be a covalent bond. So this covalent bonding can be between non-metals, two non-metals, and it can be between metal and a non-metal. Um, so let's just study about this. This is what I just told you. This is also written over here in this slide. If you want to go through this, when non-metals react with each other, or metals and non-metals when they react with each other, they attain their noble gas configuration and they share their electrons between themselves, and they then complete their valency, which is their last outermost shell. And this type of chemical bonding is known as covalent bonding, where they are sharing their electrons. So the covalent bond consists of electronic configuration as well, and this type of electronic electrostatic force of attraction. Sorry, so the atoms they have electrostatic force of attraction in this bond because of these electrons, and because of the positively charged nuclei of the two atoms which are sharing their electrons. So this is how they have an electrostatic forces of attraction because of the electrons and positively charged nuclei. So, so this is a covalent bond which is formed. Now, what we do is, for example, this is CH4, which is methane. If I want to draw this, I will be showing 4 straight lines to represent the chemical bond or the covalent bond between the C carbon and hydrogen atoms. And this one single line or straight line or this chemical bond is representing that one pair of electrons has been shared. One electron has been shared from the carbon atom, and one electron has been shared from the hydrogen atom. And carbon has a valency of carbon is in the group 4. So it has 4 valence electrons in its outermost shell. So it needs 4 more to complete and attain the configuration of 8 electrons in the outermost shell. So it has to form 4 more covalent bonds with the hydrogen atoms to complete its outermost shell. That is why it is going to make 4 single covalent bonds. For example, if these are two double bonds, then then 2 pairs of electrons will be shared. 2 pairs will be shared or 4 electrons will be shared between the two atoms. two pairs of electrons either, or four electrons. Okay, so one pair has two electrons. You can see this, the one pair has two electrons. So we just represent it with one single bond. And if it has uh, consequently three bonds or three straight lines, these will represent that three pairs has been shared, or four or six electrons has been shared. So this is a basic concept for like covalent bonding. You don't need to worry about that learning that which atom is in which group, because you always get the periodic table in the exams as well. So you don't need to worry about that. Okay. So coming to the dot and cross diagrams. Now dot and cross diagrams, they represent the covalent bonding amongst the atoms in a molecule. And these atoms, they can be identical as well, and they can be non-identical as well. So the dot and cross diagrams, they were also used to show the electronic configuration and the bonding, so the chemical bonding in the ionic bonds as well. So here are some examples which I'm going to share with you guys. Now, first off, there were some key concepts which I just told you. Now I'm going to cover a few more over here. I'm going to share with you how these bonds are formed. I'm going to explain you further. For example, the first example we had is hydrogen molecule. Now, hydrogen molecule has H2. It is represented by H2 because two atoms of hydrogen, right? So we have two atoms of hydrogen which are sharing their electrons so that they can get a noble gas configuration. Now, so if I am saying that this hydrogen atom has this is represented by the dot and cross diagram. It has a dot, which is its electron, and the other hydrogen atom has this X or a cross, which is its electron. So if I'm going to count that this hydrogen atom, after sharing its electron, it has now attained its noble gas configuration. So it has got two electrons. So this is a duplet configuration, right? And this is also a noble gas configuration. Either the atom has to complete two electrons, or it has to complete eight electrons. So either duplet or either octet configuration. I have discussed this as well in my previous lectures. So I'm going to count this as two electrons. This hydrogen atom also has two electrons, and this one also has two electrons, because now they have both shared their electrons. Coming to the next example, and if I have to represent this as in the covalent bond form, so I'm going to just make a single bond over here in between, which is going to represent one pair of electrons being shared between the two hydrogen atoms, or two electrons shared in between these two atoms. Okay. Coming to the next example, the second one is CH4, which I just told you in my previous slide. This is methane, and carbon has four electrons in its outermost shell. It needs four more, so it will form single covalent bonds with the four hydrogen atoms. So it's going to be CH4, right? All right. One more thing: if the compound has uh, metals and non-metals which are sharing their electrons, so always the metals will come first and then the non-metals. So for example, if it is any bond, for example, if I say it is magnesium bromide, supposedly MgBr2, magnesium bromide, and magnesium is Mg, and it needs to give two, either give two electrons or share two. So what it will do, it will just combine with bromine and 2 bromine. So magnesium always comes first because it is a metal, and bromine will come later because it is a non-metal. Always in the, even in the whenever you name the compound, or even if you write the chemical formula of the compound. All right. So metals always come first, and then non-metals. Then this is the third example. This is chlorine molecule, Cl2, two atoms of chlorine. So you see that chlorine is in group 7. So it has seven outer shell electrons. It is going to share one. It needs one more, so it's always going to share one electron from the next chlorine atom, right? So it will get one electron. It will become 8 electrons in the outermost shell. This is C2H4, which is ethene. So C2H4. Now here, so this is a single bond over here in chlorine. So it's always going to be Cl and single covalent bond in between. Then C2H4. C2H4 has, carbon has 4 atoms, 4 electrons in the outermost shell, sorry, and it needs to have 4 more electrons. So if it is going to form single bonds with hydrogen, then where it will get the rest of the 2 electrons. So it's going to form 2 double covalent bonds with the next carbon atom. So this will be sharing, it will be sharing 4 electrons over here. So 2 from this side and 2 from this side, right? So this is going to be 1, 2, 3, and 4. Now, like this carbon atom has received 4 electrons, and this carbon atom has also received 4 electrons by just sharing their electrons in between, right? So coming to the next few examples. So this one is oxygen molecule, and oxygen is in group 6. So it needs 2 more electrons from the next oxygen atom. So if it needs 2 more electrons, it's only going to form 2 double bonds and share 2 electrons with the next one. This is HCl, and hydrogen only needs 1 electron, and chlorine also needs only 1 electron, so it's going to form one single covalent bond in between. Now nitrogen is in group 5, so it needs to have 3 more electrons to complete its octet configuration. So it will form 3 covalent bonds, and the rest of the electrons, they remain as a lone pair. This is known as a lone pair. The lone, why is it known as a lone pair? Because it is not being or not sharing its electrons with the next nitrogen atom, right? So it's going to be known as a lone pair. And it's going to form 3 covalent bonds in between by sharing 3 electrons with the next nitrogen atom. This is a water molecule, so it has 2 hydrogen, so it's going to be H2 and then O. So 2 hydrogen atoms and 1 oxygen atom, and it's going to oxygen is in group 6, so it needs 2 electrons. So it's going to just share one single covalent bond with the 2 hydrogen atoms. I hope this is clear up till now. And now I am going to share with you that how we can form the formula of the compounds. If there are some following rules which I want to share, that whenever we are forming the formula of the compounds, there are certain things which need to be known in general. For example, the compounds are formed always between metals and non-metals, or either two non-metals. So if there is And the next thing I want to share is that where a compound contains metal, the metals, they will always come first. So always the metals come first, and then the non-metals. These points are to be noted for the. I think I should rest. Like it in here. So always the metals come first, and then non-metals. Then if there are metals and non-metals in a compound, then always the non-metals, for example, oxygen and chlorine, they are non-metals. So non-metals, they end with ite. Ite. This. For example, if it's oxygen, oxygen will convert into oxide. If it is chlorine, it will convert into chloride. If it is bromine, it will convert into bromide. If it is iodine, it will convert into iodide. So, so on, right? Then my next point is that, for example, there are certain metals which have more than one valencies. For example, if it is copper, it is a transition metal. It has one valency as well, plus one, and it also has plus two as well. Supposingly, if it's iron, iron also has plus two, and it also has plus three. So we need to know these valencies before coming up to the chemical formula of the compound. So these valencies will you will get to know about this after during the whole course of this chemistry chapters and the whole syllabus. You will all get familiarized during this whole syllabus. So you guys don't need to worry about this. Coming to my next point. For example, if there are polyatomic ions, I also discussed this in my last one. They will have different powers. For example, if it's hydroxide, it is going to be OH, and it has a power of -1. So it will have OH minus. For example, if it's sulfate, it will have SO4, because four atoms of oxygen, and it has a power of -2. So you guys just need to remember this, all right? Coming to the physical properties of the covalent compounds, I'm now going to tell you how we can relate the structure and bonding of the physical properties with of the covalent compounds. So this is my next slide. So the covalent compounds, they are usually solids, liquids, and gases at RTP, and they have a lower melting and boiling points, except for unless they are giant molecular structures, such as we discussed in our earlier lectures as well. As for example, SiO2, silicon dioxide. Dioxide. Why dioxide? Because two oxygen atoms. So di is for two, right? So we have graphite and diamond. They also have higher melting and boiling points. Otherwise, if there's a simple covalent compounds, then they will have lower melting and boiling points, because their bonds will be easily broken down by only less amount of energy as compared to with the giant molecular structures. They do not even conduct electricity except graphite and an aqueous solution of acids. So an aqueous solution of acids is going to conduct electricity, because when they're going to dissolve in water, the bonding is going to change from covalent to ionic. So whenever the molecules are going to dissociate in water, they just form ions. So the bonding just converts into ionic bonding, right? Which is why they will be able to conduct electricity from covalent to ionic. Right. I hope this is all clear up to now. Right. Coming to my next slide, I'm going to discuss with you guys some practice examples, so you all have a bit of an idea. So the first question is, which molecule contains three shared pairs of electrons between two of its atoms? So they're asking about three shared pairs of electrons. Three shared pairs means three covalent bonds like these. Right. This means this is either going to be in group 5, and we already studied that N2 has nitrogen molecule has three shared pair of electrons. It's always going to share three electrons because it needs three more electrons to complete its octet configuration. So because nitrogen is in group 5. So the first one is ACO2, no. B C2H4, C H2O, and then D N2. So this is going to be D N2. Right? And the second one is a molecule of sulfuric acid has the structural formula shown this. So the sulfuric acid is H2S4, H2S4, H2SO4. So as I discussed that sulfate ion is a polyatomic one, and it has two minus 2 power over it, whereas if I talk about hydrogen, it has a plus charge. So it's going to form H2SO4. How many electrons are involved in forming all the covalent bonds in this one molecule? So the answer for this one is going to be that they're asking about the electrons which are involved, not the pairs. So you need to be very much vigilant in this. So one pair has two electrons. So two here, two here, two here, two here, and then 4 over here, and then 4 over here. So there's going to be 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's going to be 16 electrons in one molecule, right? Covalent bond is formed by electrons sharing between metals and non-metals, or electron sharing between non-metals, or electron transferred. So electron is never transferred in covalent bonds. So C and D are always going to be incorrect in this one. They are always shared, right? And we learned that a covalent bond is usually formed between the non-metals. So electrons, they are going to be shared between the non-metals. Then the next one is, how many of the molecules shown contain only one covalent bond? So we have to check which one has only one covalent bond. So how many of the molecules will have how many of the molecules? Like which ones out of these? So we have chlorine, hydrogen. Chlorine has one covalent bond, Cl, because it's in group 7. It only needs one electron to complete the noble gas configuration. This is H2. This also needs one, and then HCl. This one also needs one because chlorine is in group 7 and hydrogen is in group 1. N2 needs 3. It has 3 bonds in between, and O2 also has 2 bonds in between. So these will be incorrect. So the ones which are left are only 3: chlorine, hydrogen, and HCl. So it's going to be 3, 4. B is going to be the correct one. Now I'm going to come to the next part. Now this one. The first question is question number 5. The diagram shows the structure of a covalent compound which contains the elements hydrogen and the unknown elements X, Y, and Z. And to which groups of the periodic table do these 3 elements X, Y, and Z belong? Now they are asking us that we have to tell that to which groups do these elements belong. How can we figure that out? We can figure this out if we know that how many pairs are being shared. So it is X is sharing 4 pairs, 1, 2, 3, 4. So it's over here also X is sharing 4 pairs, 1, 2, 3, 4. That means X has 4 valence electrons in its outermost shell. So X has to be in the group 4 because always the valence electrons, they will tell us, the valence or the outermost electrons, they will tell us in which group that um, element is in. So valence electron is equals to group. Valence electron is also known as the outermost shell electrons or the outer electrons, right? So we need to know this. So A and D are all wrong because we just figured this out that 4 is going to be correct. Now we have to figure out if it's B is the right option or C is the right option. So now coming to Y is sharing 1, 2 and then 3 here. Y is sharing 3 only, and Y is sharing only 2 pairs over here, and it is also sharing 2 pairs over here. That means it only needs 2 more electrons to complete its outermost configuration. That means it is going to be in group 6. Y is going to be in group 6 because it is only sharing 2 bonds with the next atom. So this means that it only needs 2 more electrons to complete its outermost shell. So if it needs only 2 more electrons to complete its outermost shell, that means it is going to be in group 6. So this one is going to be correct. Then I'm going to also check the last one out as well. Now Z over here is sharing 3 bonds. So if it's sharing 3 bonds, that means it only needs 3 more electrons to complete its outermost shell. That means it is going to be in group 5. So C is going to be the correct option. C is going to be the correct option. I hope this one is also clear to you guys. I'm going to the next one. So the table shows the properties of some substances. Which substance is a covalent compound? So we have to tell which one is a covalent compound. And remember that we know that the covalent compounds, they whenever they are solids or liquids, they do not conduct electricity except for graphite and aqueous solutions of acids only. So they are not going to conduct electricity in whichever their state is, whether they are solids or whether they are liquids. And the melting points and boiling points are always lower, they're never high. So the lowest melting points, and they are not going to conduct electricity even, and they have the lowest melting points. So this one is going to be correct. Does not conduct electricity, does not conduct electricity. So this one is going to be correct. Then we have 6p. It's going to be 6p. Which two statements about a covalent bond they are correct? Question number 7. So the first one is it can be formed between two metal atoms. It can be formed between two non-metal atoms. It is formed by the transfer of electrons between the atoms. It is formed by the sharing of the electrons between the atoms. So we already know that the electrons, they are shared between the atoms. So this one is absolutely correct. So we have 4 in this one and we have 4 in this statement. So we just negate part. We just negate C as well, and we also going to negate A. Now we only left with B and D. So we have to check if 1 and 2 are correct or not. So the covalent bonds they formed between two non-metal atoms. So it's going to be 2 and 4. These are going to be correct. 7, D is the correct one. They have asked about that which statements are correct about the covalent bonds. They are going to be formed between two non-metal atoms and they are going to be sharing electrons between the atoms. So these were a few questions regarding and few practice examples regarding the covalent bonding. I hope this is clear to you guys, and please ask me questions if you have any, and please comment down with this video, and I'm going to reply to your queries. Thank you for watching. Stay with us and happy